All right there, AP Chem Scholars, Section 4. This is going to be a very short video because honestly, I talked about a bit of this idea already in Section 1. Don't know why they didn't merge them, but then again, don't know why I didn't merge it. So, hey, what are you going to do? All right, so we talked about the idea of physical versus chemical changes already. A chemical change defined as something a change that results in a new substance with a new identity, or you could view it as a new set of properties. Okay, so when I burn wood, okay, or paper, the material I formed has completely different properties than the paper does. Okay, when I rust or oxidize iron, the rust that forms is very different than the iron. It's nowhere near as strong. Okay, we've gone from a metallic solid to an ionic solid, and we're changing the properties around. Okay, so definitely a different set of properties. By contrast, physical change, not chance, physical change does not result in a new identity, but an alteration of one or more properties. So if going back to my example about paper, if I rip a paper in half, I've changed the appearance of the paper, but it's still paper. Okay? That is a physical change. If I boil water, it's still H2O. I have not changed that. That is a physical change. And another one that throws people off is the idea of solutions. Okay, when I make a solution, okay, if I throw salt in the water, it's the sodium and chloride ions are there. The water is still there. It's still going to have the same properties that it would have had otherwise. So it is a physical change, not a chemical change when we make a solution. That one comes up a lot. All right. So yeah, exactly what I was just talking about. Okay. People often think of phase changes as being chemical changes because sometimes we use heat. All right, so it has heat, but it's still the same substance. Okay, in terms of on a molecular level, it is the same thing. Okay, and again, the solvation process, making a solution, means we're going to have the same thing. Okay, if I evaporate out the water, the salt or the sugar or whatever the solute is right there. Okay, again, maybe I've altered its appearance a bit, but it is still there, and I can separate the water and the sugar without a chemical means. Okay, so it can be done easily. That is a physical change. What a chemical change really is about bonds, right? That's where the new identity is coming from. Okay, the fact that we are moving electrons around, that we are changing the material around. So when we are breaking bonds and making bonds, that's really what a chemical change is about. So, it's the huge difference between talking about sodium and sodium chloride. People talk about having a low sodium diet. Well, they're really not talking about sodium because pure sodium is not something you would ever want to ingest. But sodium chloride, sodium monosodium glutamate, and blah, 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 all these other sodium citrate. There's all these sodium-based compounds that we do ingest, and that's okay to ingest at least to some extent, right? But pure sodium, bursts into flames when it's in water, so I'm thinking that's kind of bad. So there you go. Chemical physical changes, that's really all you got to know. Homework is due tonight. Get it done.